Well, he's one of the IT guys. He's still going on campus, but he's now moving from Roedean to a company. Okay, right. Oh my goodness gracious. Wait a minute, what's happening? If you'd like the fan on, you may turn the fan on. Okay. And that. Harry, I'm afraid. And to say you're doing all right, good job. Right, okay. Right. Definitely probably happy. Rick, you know, no. Um, example. Whoa. Um, okay. So now, in this question, okay, what's our first step? If we have segmentation, what do we want to do? Okay, expand it, get rid of the segmentation, right? So let's go sort that out. Don't like the segments. Yeah, what was that? Okay. All right, so go write that as a theory. And Laurel and Hardy, what you got here? First term going to be 11, right? Next one's going to be going up in 4s, right? Plus 15, plus 19, plus dot, dot, dot. And so what's the last term? 4n plus 7, right? So we required to prove, forget about the segmentation, okay, that 11 plus 15 plus 19 plus blah, 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 plus 4n plus 7 is equal to n times 2n plus 9. Okay, so this is what we're going to try set out to do. Okay, what's the first thing we have to do? That the first domino can fall, right? So prove and true for n is equal to 1. And then we've broken the lesson. I would do it like this. On the right-hand side, I wouldn't do the left-hand side. Okay, so for n is equal to 1, what does that mean? You add up the first term on the left-hand side, what do you get? Left-hand side is equal to 11. The right-hand side, I'd probably just show a bit of a working. Okay, the right-hand side would be equal to 1 times 2 times 1 plus 9, which is 11. So that the first domino can fall, right? So what have we shown? Okay. So therefore, true for n is equal to 1. Do next. We make an assumption that one of the dominoes randomly can fall over. So we assume it's true for. Good. Assume true for n is equal to k, where k is what type of number? Right, now go write down your assumption in math. So later, in math, what we're going to assume? 11. Thanks so much. Much appreciated, Victor. Right, so I would highlight that for your little star in. What are you with us? Percy, tell me please, what do you have to try to prove now? The next domino will fall over, in other words? Okay. So, it's a bit tedious and stuff. Required to prove true for n is equal to k plus 1. So, in other words, Alison, Ali Pali, tell us please, Ali Pali, right? What do we have to prove? In mathematics, how do you prove what we're required to prove in mathematics? So now, n is equal to k plus 1. In other words, in this example, what do we have to prove? 11. Plus 4k plus 7 plus k plus 1 plus 7. Okay. Yeah. Is equal to?
Equal k plus 1. 2k plus 1.
Right. Okay. Everyone with me on that? Okay. You get a mark for saying what you're going to try to do. Okay. So that is what we're going to try. To do that, we need to use our assumption, yeah? No, wait. Allow me to finish your popcorn. Is it very long? Take the teeth, okay? Right, boy, Jamal.
I don't really understand that whole paper.
That's just the second last term. So this is a term. This is term 1, right? This is term 2. This is term 3. This is term k. The last term in the series is 4 times, and this is term k plus 1. You with me? But we need term k because we're going to use that in our assumption, right? To sub in the assumption. Okay. So if you want to save a bit of time, so the left hand, so the actual then I write down, I'm going to start proving this thing. I thought, tell me please, what we're going to do in our proof. That's the Irish, you idiots. Right, okay. Right. Stick to Russian. Okay, what we're going to do here?
We're going to
What we're going to sub in?
start.
Okay, so what are we going to replace this with? A times 2k plus 9, do you agree? Okay. So get for k times 2k plus 9. Okay. Plus what? What's left on the left-hand side? Don't forget, you've still got this guy over here, right? Okay. This puppy here. Plus 4. Okay, plus 1. You can skip out some steps. Plus 7, right? So this is the left-hand side. And what can we do? We can either go and probably it's going to be just times up. So the left-hand side and the right-hand side are the same. Okay. Right, carry on. That's the left-hand side. Did you get that? Thanks. Okay. And the right-hand side is going to be k plus 1, 2k plus 11, right? Which is 2k squared plus 13k. Quite warm today. Yeah, probably. Enough today. Right. So I get 2k squared plus 13k plus 11. Do you agree? What can I say now? Right. Okay, right. Emma, go first. Give us a speech.
Therefore, LHS equals RHS.
And therefore?
Therefore, true for n equals k plus 1, 7, true for n equals k, and true for n equals 1.
And therefore?
Therefore, true upside down a.
How do I read upside down A?
For
That's true. Therefore, true.
natural numbers by m.
True for all n is an element. Do we say for all natural numbers? Yeah, that's fine. By principle of mathematical induction. You'll kill me today. You'll kill my Astro. Stand up 3 times today. I'm going to like point up. Yeah, right. I'm going to start an athletic machine, right? Yeah. We should say for all n is an element of natural numbers, that's better. Right, Barry. Okay, what's next, guys?
Wait
Okay.
a moment. Oh.
Let's start. That is about proof. All that start actually with the natural numbers.
Actually,
Oh, that's proof. Without proof, there's nothing. Without limits, there's nothing. Without natural numbers, there's nothing. Without vodka,
there's nothing.
right. No joy. Okay, so induction is awesome. Okay. No life, no love. Right. So this is a formula that you're going to use. It is not gone. Okay. This is a formula you're going to use in Comax. Okay. But you're not going to have to before because those are just they don't know and they just assume it. We are why? Because we are the bar. Okay, right. Okay. Go do this up. Start.
I cannot.
Can do it. Back to us. The Scottish English.
Yeah.
Oh, what a great idea. Okay. And this is not because you want to miss any teacher time, eh? Well, by the time I set it up. Okay. Okay. Right. So, you don't understand. What do you start to do? What's the letter we're working with now? Now, guys, A. Okay. We work with N, right? Okay. We work with an that's so. The first thing is for N is equal to? Right. So go. Okay, so for n is equal to 1. What do you got? Yes, but the n is the thing you're working with. The proof revolves around the equivalent for all naturally. So, just by the way, okay. If n was equal, this is, again, sometimes you guys do this stuff and you don't know what the hell you're actually doing. What does actually, if we can prove this, what could we say? Okay, that if n was equal to 15, okay, instead of working out, okay, whatever r is going to be a number which you can sub in. Then 1 plus r plus r to the 15 plus r squared plus dot plus r to the 15. You could choose a random number for r and sub it in there. Okay, so you in ascending powers. Okay, plus r for any 15. The last term would be r to the 14. That's n minus 1, right? So 1 plus r squared, okay, plus r cubed, plus up to r to the 14. Instead of working out that, plugging in all of those numbers, whatever you chose to be r, what could you rather do? You could say it would be equal to what? A lot quicker. Because if we can prove this is saying we're proving that this will always be true. What we're doing now is proving this will always be true. Once we prove it, we can use it. Okay, so we can prove this. Okay, if I then said to you, okay, hence given r is equal to a half, okay, go evaluate. So I'll give you a question at the end of this. Okay, because then we can go use it. That's the point of proof. Okay, once I prove this for all natural numbers, I can use it for any natural number. Is that right, Roger? Yes. Okay, good. Okay, as long as you understand, that's the main thing. Okay, right. Okay, so for n is equal to 1. What is the left-hand side, Boris?
1.
Left-hand side is 1. No, you are Boris from now on. No, sorry. Boris is Milosh. Sorry? No, sorry. Milosh is Czech. Okay. No, you can't steal her name. They should be very upset. Meaning she's Russian. She'll kill you. Right. Okay. All right, Milosh, you can be Milosh. Right. Okay. So the left-hand side is 1. Okay. Right. Tell me, please. What's the right-hand side going to be, please, Ria? Why? So place over r minus 1 is equal to. I stopped them, that's why. And now we've changed the plan. Right. So what can I say? Plot. What can I say? Plot. Okay. Well done. Right. Right. So I proved it's true for n is equal to 1. Right. The next step, please, Voyager. Okay. In other words, Voyager, what do we have to assume? Ah. That, hang on. Yeah. Thank you. Sorry. I'm ahead of myself. R to the k minus 1, yeah. R to the k. Be careful where the ones are, eh? On the left-hand side, they're in the exponents. On the right-hand side, they're on their own. So this is my assumption. Blah, blah. Yes. That's what we have to use. All right, then what you're going to try to prove. Why you guys so quiet today? Okay, so What do we have to do now, Emma? Prove 4. Right, good. So in other words, for the next one. In other words, what we're trying to prove mathematically. Yeah. Why to prove? Yes.
One.
One, keep that one. Remember that, what's that thing over there, Boyja? That term K, right? K. Remember, this is R to the north. This is term 1 K. This is term 2, right? So that term K. We're trying to prove it's true for term K up to term K plus 1, right? So what's term K plus 1 going to be? I'm going to replace K with K plus 1, right? Okay, so the last term is equal to R to the K minus 1, right? It's 1 less. So it's going to be plus R to the K plus 1 minus 1. Do you agree? Or just R to the K? That's the thing that we've added.
And then it's equal.
And we're trying to prove it equal to what, Emma? Careful, we prove it true for n is equal to K plus 1. So this is for n. This is for n is equal to K. So for n is equal to K plus 1, what's it going to be? R to the K plus 1 minus 1. No, because we're assuming it was true for the first K terms. That's what for n is equal to K. We're trying to prove it's then true for the next term, for K plus 1. Yeah. Yeah. Because we want to remember, Emma, we want to keep this in our proof. Well, now, the way I don't mind you saving a bit of time in this. Hey, look here, Peter. Instead of writing left-hand side, okay, and rewriting that whole bit, just write immediately left-hand side sub in star. Yeah, it just saves you a bit of time.
Do you write something?
Yeah, I would just explain to the marker what you're doing. Yes, but remember, we pushed for time in AP. So left-hand side, sub in star. Okay, so you're going to replace the bit in yellow, okay, with our assumption. We assume. Okay, so this is. So you're replacing this. You're replacing this with R to the K minus 1 over R, because this is equal to that. We assume that this was true. So this is that part, and we can't forget about this thing on the right here. So, Gulash, tell me the next line. Over. Yep. In other words, just R to that. It's 1 minus 1 Gulash. But we have only 4 pawns. I see pawn. It's going to bear loan. You have 5 minutes to just make it disappear. You can give. Oh, bullshit. Yeah, right. Who would like to give pawn now before? No, you have my hand in your body. Have you had it? Oh, I do apologize. Now we are French. Yeah. A good student. You and your mom. Unfelt it all. Where are we? Okay, so we're trying to prove that equal to the right-hand side, right? So, can give me any suggestions? On the right-hand side, there's a common What's at the bottom? This is Russian, half French, half Russian. Right, okay. So what are we going to do? Place human over here. Nice. Let the other humans, the mortals try. Mortals try. Right. Not me. Carry on. Multiply powers, add exponent. Right. Let the humans try. Nine. From denominators, multiply powers, add exponent. Yeah, exactly. Nine. No, I need to think a little bit. Not that much. So what happens, Vladimir? Okay, gone.
And then you create just after the K plus 1.
And why is that lovely? Because that is the Vladimir. I am so proud. The right hand side was that, and look. And then we, have a whole speech. Right, and then just write speech. Let me have a try speech. Okay, go please. Who's trying? Smallpox. Right. Okay, what? Where did that come from? Yeah? Smallpox? Go, but that's what you are. Yeah, you smallpox. Who's going? Smallpox. Are you smallpox? What are you? Are you smallpox? Who's going?
I'll be cowpox.
Okay, cowpox, go.
Okay.
Your speech. Therefore.
So you go therefore, I'll let people argue.
Yeah. This is your special. N is equal to K. That's correct. Therefore, so not say upside down A. Right? Now, Miss Clark at St. John teaches right, therefore, by PMI, true for all n is the element of natural numbers. I will accept that, actually, I think, because I just trust Miss Clark.
Wait, so what?
Good mathematician.
But she's.
She said that.
We don't like it, we must deal with.
Cannot kill Miss Clark. She's unkillable.
I will
She
kill her.
runs
I
marathons.
will kill her.
Drinks vodka while she runs marathons.
I
She eats little puppets like you for breakfast. Okay. For you, for her, you don't even exist. You are like a little fly buzzing around. She's what you when you've gone. Now look what you did. Okay. Right. Why? The lightning is going to kill me. Right. Okay.
No, that's not right.
We need break. Right. You can have break. Right. Right. Every human needs to stand up, walk outside class. I'm going to close now. Go talk to humans. I don't care about those Irish little slack. No, it's not this. Bad, right, okay. Okay, right. Yeah.
One of us dies before you.
Yeah, okay. Okay, right. I'm not speak any Russian this lesson. Okay. So we need a little bit of context.
Oh, no.
Watch out! Nothing. You behave. Okay. So, everybody focus. Give it again. Feel your arm on the chair. Just be an idiot. Right. Okay. I'm recording. Okay. Right. No, man. Okay. Right. Okay. So, right. In these ones over here. Okay. We started the same. So what we're trying to prove here is prove that 7n minus 1 is divisible by 6 for all n is an element of natural numbers. Okay. So if that's true, what does it mean? It means we know for sure that 7 to the power of 19 minus 1 is divisible by 6. Who knows? When you need to know that. Maybe somebody comes up to you, about to kill you, they say, I'll let you know. You can tell me, is 7 to the 18 divisible by 6? And you'll be like, oh, it's binding up. Yeah. That's what you do. Right, okay. So, right. So there's a different way of proving these. So firstly, we prove proof for n is equal to 1. Once again. So I say 4n is equal to 1. There's no left-hand side and right-hand side. That is God. Okay.
So you have to say proof there.
No.
Why easy?
For n is equal to 1, what do we get? We get 7 to the 1. What? No?
7 to the 1 minus 1, which is 1.
Which is not divisible by 6. Question over. Must be for n is element, you must add a little thing here.
Oh.
N is bigger than or equal to 2.
Oh.
No, I've done mistake. What's mistake? I've done question. The 1 is where it should be. Where should the 1 be?
You tell us.
Okay.
Oh, it should be minus. Yeah. Yeah.
Good recovery. Yes, we can. Yeah. Sorry, I'm just checking new work. Okay. So, for n is equal to 1. Wager, what's this going to be? When I'm summing 1, what I get? Because summing n is equal to 1.
1. Oh,
Which is 6. Okay. Okay. And 6 over 6 equals 1. Therefore, true for n is equal to 1. Tough stuff, right? As we've just started. Okay. What I have to now do, I have to assume what? For couple of that Russian accent to it. I don't know what's going on there. Assume true for n is equal to k. Okay, so what is our assumption? I assume Java 7k minus 1 is divisible natural numbers by 6. Okay, now in these ones, so that's our assumption, but that's what we're going to use. Okay, we're going to rewrite our assumption, okay, mathematically.
So we have to say divisible. Right.
That's fine. Okay, right. So now, guys, if something's divisible by 6, what does that mean? Well, if 36 is, well, 42 is divisible by 6, why? Because 42 divided by 6 gives you 7, gives you a natural number and no remainder, right?
Yeah.
700 divided by what? 6. 600 divided by 6 is equal to 100 with no remainder. So your answer is a natural number and there's no remainder. So if 7 to the k minus 1 is divisible by 6, okay, I'm assuming that 7 to the k minus 1, wait, no, we've still got to work with our assumption. We've got to change, unlike the previous one, okay, we've got to change our assumption into math and manipulate that. So we're assuming 7 to the k minus 1, what are we dividing by? If I divide it by 6, what happens?
Equals natural number.
I get a natural number, right? Let's call it P. Okay. We call it anything but not K.
And you must say when P is
We've used K. Okay. Yes. Well done. Now, okay. 7 to the k minus 1 over 6 is equal to. Okay, we'll see. Okay. So cow, this cow not good. Okay, right. So now, just wake up, Rose. Okay. Now, she needs to pay attention to this. Right. Okay, listen. So now, we'll keep going back to Russian. Okay. Now, okay, you want to isolate the power. So this is still our assumption, guys. Okay. Isolate power in our assumption. So what's the power here? In this statement over here. Not just K, that's the exponent. What's power? What's power? 7 to the K is power. Right. 7 to the K is power. Right. So go get 7 to the K minus 1. No, you do not have the right explanation. Really the right intent. So tell me please, I'm going to speak well now. Tell me please, Becca. How do I get 7 to the K on home? Lovely. Okay. What Becca did? It was evil powers. Okay, well, she did that. And then, in her moment of sneakiness, this is how Becca stole the vision. Right. So, wait. Are we happy with that? Why not? No, you cannot get K by itself. Yes, you can use the log, but then what? Okay. Right. Okay. So this, guys, is still my assumption, right? So this is the puppy. We are going to put a star there, and we are going to use this. This is still my assumption. It's all just manipulating the assumption. What was the assumption? That it was divisible by 6, because that's what we were trying to prove, right? Where n is equal to k. We should have said here, k is an element of natural number. Okay? Then, because we said it's divisible by 6, there must be some natural number out there. If I divide by 6, it's equal to that natural number. Then, when we do the proof, before we do the proof, isolate a power. That's generally the best method that works. Okay. You can not do this thing so well. Right. Okay. So you need to listen to Boris' method. Okay, right. So what we're trying to prove. Now we're going to go to Emma, what we're trying to prove.
What?
Yes. Okay, good. Well said in Russian. Thank you. Okay, right. Right, fire. Okay.
The power.
Look, what we're going to try to prove.
No.
Shut up. I got what I want. Right. What we're going to prove. It's true for n is equal to K plus 1. So we're trying to prove 7 to the K plus 1. Okay. Minus 1 is divisible by 6. Okay. So what do I have to do now? We have to force our assumption into the sum. Okay. So do not write this down, Emma. Okay. Force assumption into sum. Did you count? You with me? Yeah, but now it's count. Okay. People like to scout.
You know when you call people a cow, it's not very nice.
No, it's quite right. If I call them big fat cow, then it's not nice.
Okay.
Little cow, nice.
No.
Everyone loves a little cow.
No.
If there's a little cow here now, you go, hello, little cow. Right, okay. Not little cow. Right, okay. So now what? How do I force 7K into this term? 7K plus 1 is the same thing. Well done. It's going to be what? So my proof, 7K plus 1 minus 1 is equal to 7K times 7. Do you agree? I should have said that before this. Required to prove true for n is equal to K plus 1. No. Okay. We're going to show that this is going to be divisible. So I'm trying to prove that that thing is divisible by 6, right? Do you agree? That's what the proof said. Proof way back then said that we have to prove that 7 to the n minus 1 will always be divisible by 6. So we assumed, what did we do? We assumed that it was true for n is equal to k, right? This was all this bit over here was all just manipulating this bit here. You want to highlight this in one thing. This was all just manipulating the assumption. Now we're starting with the actual proof over here. So this now is the actual proof. And the proof is we've got to required to prove that it's true, thank you, Emma, for n is equal to k plus 1. Okay. Sorry, this was my lines have gone wrong. This should be put that. Okay. So now I've got to prove it's true for n is equal to k plus 1. In other words, so we'll get there now. So required to prove 7k plus 1. So then I've got to go back to that and say I've got to somehow force this tuppy in here, right? So 7k plus 1 is the same thing, you will agree, as 7 to the k plus 1 is 7 to the k times 7. You get that? 7 means 7 to the 1, right? Then I've still got this minus 1, right? Now what can we do? Now put 7k in, right? Okay, so I start in star. Yes. Because it's still relying, by the mathematical induction, still relying on proving it's true for 1. Proving it's true for something. Therefore, yeah. Therefore, true for all any elements of that number stuff here. So, Vladimir, if I sub this in, what do I get? Oh, Vladimir. Vladimir, respond to your name. God's sake. Right. 7k is what? 6p plus what? Okay, times 7. This is how you understand. Okay, so it's going to be 6p plus 1 times 7 minus 1, right? Okay. Yeah, you with me?
Yes.
Okay.
I am actually 2 steps ahead.
Oh, fancy to cow. Right. Okay. So I sub that in, right? Now, guys, if something is divisible by 6, what should you be able to take out as a common factor? So whatever, ultimately, you want to take out, this is not, okay, don't write in test. As common factor, what you're trying to prove divisible. Take out as a common factor. That's
Of what you are. what do you need to sub into?
What you're trying to prove is, so yeah, I'm trying to prove it's divisible by 6, right? To prove it's divisible by 6, what I ultimately have to do, I have to take out 6 as a common factor. If I do that, I'm done. Finish. I can take out 6 as a common factor, it's divisible by 6. With me. Okay. So I'm going to try to take out 6 as a common factor from here. How am I going to do? Then take out as common factor what you're trying to prove it's divisible by. Take out as common factor what trying to prove divisible by.
So we take out.
So how do we take? First we times out. So I get
You get
7 or 7 times 6b.
42b
Yes,
plus 7 minus 1
good. Which is
equals 22b plus 6.
good.
Then you take 6 out
Where do we take 6 to?
outside.
Somewhere nice. Nice little restaurant.
There you go.
Okay, so I get 6, 7b plus 1.
Yeah.
Okay. So therefore, divisible by 6. And therefore, prove for n is equal to k plus 1. Okay. And therefore, prove. So we're just going to write this now. Okay. For all what? This cow. What do we, this is your little specialty.
Natural numbers.
N is an element of natural numbers by. You know, you must mention no true for n is equal to k plus 1. So if you're just going to finish it with true for n is equal to k plus 1, therefore true by principle of mathematical induction. Yeah. That makes sense then. Okay. So what were our steps? Okay, when we're proving divisibility.
Okay,
So what do we do first, Emma?
for any
Right, for n is equal to 1. Then what? Our assumption is true for n. Okay, now, when I do our assumption, now there's going to be more work to do with the assumption. Okay, if I was going to prove this is divisible by 15, what would you do? You'd write something, whatever you're trying to prove is divisible by over 15 is equal to t. Right? Then what do you generally have to do? Yes, and then you have to isolate that power, a power, right? Isolate a power, that's still your assumption. Then what do? You try to prove it's true for n is equal to, okay, you make fine parity for n is equal to k plus 1, right? Pick up. Yeah, right, for n is equal to k plus 1, right? Okay, I'm talking to myself. Anyway, I'm going to let you do this. I cannot stop studying. I had slightly Russian accent, right? Okay, what is the time? Bye, guys. Bye, guys.